Welcome to your daily AI News Digest for March 17th, 2026, sponsored by bestai.org. We're coming to you from NVIDIA's GTC conference here in San Jose, and let me tell you, the announcements today are more than just updates. They really feel like they're marking a fundamental turning point for the entire AI industry.
So what's the big theme? The main takeaway from everything we're hearing is this: the AI honeymoon phase is officially over. The days of just speculative excitement are gone. We've now plunged headfirst into an industrial reality where the focus has shifted from fun generative novelties to actually building autonomous systems and, crucially, the massive infrastructure needed to power them.
And that brings us right to our top story today. You know, the biggest news isn't some new model or a fancy algorithm. Now, it's the physical, tangible reality of what's being called the AI factory, the hardware that's going to underpin this entire revolution. Let's just start with a single number: 227 kilowatts. Now, to put that into perspective for you, that's enough energy to power dozens of homes, all of it concentrated into one single server rack. This is the thermal design power for a new AI system from ASUS, and this immense energy density really defines the single biggest engineering challenge for AI in 2026, just dealing with all that heat. So how do you manage that kind of heat? Well, the industry has made a huge definitive shift. The old way, air cooling, it just doesn't cut it anymore. What we're seeing here, direct-to-chip liquid cooling, has basically become mandatory technology. It's the key that unlocks a staggering tenfold increase in performance per watt, and it's what makes these new AI factories even physically and economically possible.
Okay, so what are the strategic implications of all this? Well, first, the way we think about computing power has to change. The fundamental unit isn't the individual GPU anymore. It's the entire pre-integrated rack. And this, of course, raises the barrier to entry for serious AI competition to a level that, frankly, only a few global players can even afford. And maybe most critically, managing heat, what they're calling thermal governance, has gone from being a simple utility cost to a primary driver of actual performance.
All right, let's switch gears from the hardware to the software that it enables. The defining software trend of 2026, without a doubt, is the rapid shift from AI that just retrieves information to AI that actually autonomously performs tasks. The term everyone is using is agentic AI. The core idea here is to move way beyond a simple question and answer model. We're talking about systems that are designed to execute complex, multi-step workflows entirely on their own, from the very beginning to the very end. And this new paradigm has almost immediately created a huge divide. If you look at the slide, you can really see the two competing philosophies taking shape. On one side, you've got OpenClaw. It's community-driven, it's gone viral, but its open nature has also led to some major security vulnerabilities. On the other side, you have NVIDIA's answer, NemoClaw, which is built from the ground up for the enterprise with security as its absolute top priority. This really highlights the central tension of this whole agentic era. Do you go for rapid, open innovation or for secure, controlled deployment? The impact of this shift is just profound. The basic economic unit of value in AI is no longer a generated word or a generated image. It's now the successfully completed task. AI is making a huge transition from being a really sophisticated search engine into becoming an autonomous digital coworker.
Now, as you can imagine, a technological shift this big is forcing major realignments in corporate strategy. And at the same time, it's creating some completely new challenges on the legal front. So across the entire industry, we're seeing this clear trend toward focus and, well, profitability. First, OpenAI is reportedly cutting back its more experimental side quests, think of the Sora video generator, to really double down on its core enterprise business. Second, you're seeing these massive partnerships form, with Apple now officially integrating Google's Gemini into Siri. And finally, underpinning it all, you have hardware providers like Dell reporting a 2.6 times return on investment for their customers, proving these massive AI factory investments are really starting to pay off. The message is loud and clear: the industry is maturing. And on the legal side of things, a huge lawsuit was just filed today. Encyclopedia Britannica is suing OpenAI. Now, yeah, it includes a copyright claim, but the really novel argument, the part that has everyone talking, centers on this point: that AI hallucinations that make up false information and then falsely attribute it to Britannica are causing direct damage to their reputation and their trademark. This could be a landmark moment, truly. If this lawsuit is successful, this legal theory could set a brand new precedent.
It would mean AI labs could be held liable not just for the data they copy, but for the falsehoods they invent and the reputational harm those inventions cause. It's a fundamental challenge to how we currently define liability in this space.
So, despite all these incredible advances, the industry is really grappling with a growing crisis in how it even measures progress. We're seeing models that achieve superhuman scores on tests, but then they often fail at practical, real-world tasks. People are starting to call this the unreliable intern problem.
I mean, on the one hand, the progress on abstract reasoning is nothing short of remarkable. Take a look at these scores on the ARC-AGI-2 test, which is all about novel problem solving. You can see this clear progression, right? Google's Gemini 3.1 Pro is leading the pack at an incredible 77.1%. On paper, this suggests these models have a real, genuine ability to figure out new logic. But here's the problem. Here's the reality check. When you test those same models on the Apex Agents benchmark, which simulates actual professional work, the results are pretty sobering. That leading Gemini model, it only completes about a third of its tasks successfully. The others are even lower. This just reveals this massive gap between being good at abstract reasoning and being able to reliably execute in the real world. So the consensus forming here is that the core problem isn't about raw intelligence. It's an issue of orchestration. It's about the ability to manage different tools, to maintain context, to follow a coherent narrative over a long, complex project, just like a real intern has to learn. Solving this is now the next great engineering hurdle for the entire field.
So, to wrap up our digest, let's look at where this powerful, developing, and yes, sometimes unreliable intelligence is actually being deployed. We're talking from the frontiers of science to the final frontiers of space.
And it really is being deployed everywhere. In the world of science, we have the Genesis mission, with the incredible goal of using AI to compress a century of biological discovery into just a decade. In space, NVIDIA's Space One module is now bringing real-time AI processing to orbit for the first time. And then, back here on Earth, humanoid robots are finally leaving the lab and walking onto factory floors at companies like Toyota and Hyundai. And this really brings us to the central, most important question of the day. Artificial intelligence has officially left the chat box. It's now in the physical world. It's in our labs, it's in our factories, and now it's even in orbit. So the crucial challenge for the year ahead is this. What happens when the unreliable intern is everywhere? That's the digest for March 17th. Thanks for joining us.